This is Jim Kuiper from Argonne National Laboratory, and I'll be talking about the Energy Zones Mapping Tool today, especially a new corridor route generation tool that we've been adding over the last several months. And in general, I'll start out with just some slides and talk about the project. The tool itself was developed originally for the Eastern Interconnection States Planning Council, and it was a cooperative effort between three national laboratories, Argonne National Laboratory, I'm from Argonne, Oak Ridge National Laboratory, and the National Renewable Energy Laboratory. It was a good collaboration, and the other two laboratories provided quite a bit of subject matter expertise about energy technologies and available data sources, kind of review and design of models, and a lot of other project activities. ICEPIC, as we like to call it, with that acronym, is that blue area at the upper right, which is, well, their interest area is the Eastern Interconnection. So that covers 39 states and some sub-areas within them, and it's pretty much the U.S. east of the Rockies, except for parts of Texas. And it's really comprised of public utility commissioners, folks from governor's offices and state energy offices, and a lot of other key government agencies and representatives that are involved in energy planning, and also legislation related to energy policy. And the original funding was from the Department of Energy, Office of Electricity Delivery and Energy Reliability. Original funds were part of the American Recovery and Reinvestment Act, and the current project is continuing to be funded by the Department of Energy with their operating funds. So the tool is publicly available, and upper right there is the home page. The URL is at the end of the presentation, or you can look it up. It's eispctools.anl.gov, and it has really four major characteristics: data, models, reports, and policy information. And I'll be showing you most of that later in the demo, so I won't elaborate too much on that. And it was really designed for the ICEPIC members and their planning activities, but it's applicable to all these other stakeholder groups and really is intended for them as well. And on the bottom right, you can see the energy resource categories that are included. So each of these resources is used to generate electrical power, and each of these is low or no carbon, and that's the main reason they were selected. The tool is pretty unique. It's a pretty large effort. There are a lot of web applications out there, and it's a little bit daunting when you first get into it, but it's quite a significant resource. And it has the best available data that based on the recommendations of technology focus teams and other subject matter experts that participated in the work. And it's a major advantage to have all that information in one tool as opposed to in a set of disparate databases or interfaces. Beyond just data, it provides a tool for suitability mapping. So you can take a whole variety of siting factors and use the computer to help predict areas that would have the highest suitability for a particular energy generation technology. Today we'll be talking about corridor tools, so those are also useful. I mentioned the energy generation. On the home page, without registering, you can access the energy policy database, and that has over 2,400 policies related to energy development and regulation that would be needed to consider when you're planning or working with energy projects. Energy infrastructure data is something that's not generally available in a web application, but that's licensed on this site, so I'll give you an example of that. The database is actively kept current. There's a pretty diverse user community, so we feel like the tool is useful to a variety of folks, and we've made the user interface as easy to learn as possible with instructive videos, hard copy help, and these demonstrations to show you how it works. Obviously, I won't go through all these. This shows you the variety of data sources that went into this tool from many different agency levels and organizations. The one in red there, World Resources Institute, we just added 2 layers from that organization related to water. So as an example of tools and how this one relates to them, and I want to stress that each of the ones in blue are valuable websites with capabilities that we don't have in this tool. So they each have their purpose and scope. So the unique thing about the Energy Zones mapping tool is its broad scope of energy categories. And if you wanted to dig deeper into these other categories, for example, NRC Facility Locator has more about nuclear power plants. On the lower right, Wind Prospector, the Great Lakes Wind Atlas, and USGS Wind Farm each are useful websites for wind energy. This is by no means comprehensive. There are literally dozens of websites, interactive web-based mapping applications to study energy and environment and the same topics that we have in this tool. Here's the shot of the energy infrastructure data. So publicly available layer, there's one from FEMA that is somewhat limited in terms of its accuracy, scope, and currency. And in contrast, the map on the right was created within the tool, and it shows data from Platts, which was commercially licensed for this project. So you can click on any of those lines and get information about those transmission lines. The different colors represent different capacity levels. So today I'll be concentrating on corridors, and many of the updates that you see shown on this slide were released in version 4.0, and some of them were locked until we finished testing and populating everything. So that center icon in the top left, corridors, leads you to the corridor tools dialog, and the suitability models tab is where you would start, at least if you're going to be generating routes. So you can use a model to generate a corridor suitability surface, and I'll go into what that means. And then once you have that model, on the lower right there you can see generate from endpoints. That's where you specify the endpoint locations on the map and request the system to compute a route for you. Okay, I think this is my last slide. So here's some other recent updates. Just each time we do one of these webcasts, there's a few things to highlight that have happened recently. You can see we're adding a variety of data related to climate change, and that's part of a task that's ongoing this year related to water resources and energy. That viewshed sample is, and that's the map that's there, has been an interesting effort. There's a person, Brent from Kansas State University, has an algorithm that computes visual magnitude. And if you are familiar with viewsheds, they're typically calculated as what areas can be seen or not seen based on a certain vantage point. And you might count the number of places visible from multiple vantage points. What this algorithm does is not only do that, but it takes into account how dominant the feature is in the terrain. Is it facing you like a cliff face, or is it just a gradual slope in the distance? So it takes proximity and the relative angle into account to generate visual magnitude. And that map that you see there was generated at 10-meter resolution, and each step along that portion of the Appalachian Trail was computed sequentially. So you've got hundreds of viewpoints, and it really creates a map of visual magnitude from the Appalachian Trail. So the layer I'm showing there is just a sample. It only covers part of the trail in the northeast, and I'll be showing you some of that today. There's also a protected lands composite layer that takes a lot of protected lands categories and ranks them by their sensitivity. And we got some feedback from the National Park Service that some of the sensitivities of their properties were underestimated. So the recent update has to do with increasing the sensitivity of National Park Service jurisdictions, and that includes not only national parks but things like national seashores, battlefields, and a lot of other places that are pretty highly protected for development. And then I'll be showing you a lot of the interface updates today, so I won't dwell on those changes too much at this point. One thing I want to do is make sure that everybody feels comfortable asking questions, so the phones are open. If you'd like to ask, feel free to chime in at any point. I'll be glancing at the chat window, so if you send a chat message, I should see that. But don't hesitate to use the phone and dial in or speak up. Okay, so I'm going to switch to the tool itself and get onto the home page here. So real quickly, the policies is here on the home page. There's some other background information about the energy resources and how they work in terms of technologies, basically fact sheets on each energy resource. The data in the tool, you can take a look at what's in the tool, and if you click the plus, it'll tell you when it was last updated and let you access metadata. So you can do that without registering. And then this policies and regulations page, in a newsletter we just sent out, the state of Texas just had a challenge for their renewable portfolio standard. So if you wanted to take a look at that, you can filter on Texas and renewable portfolio standard and click search, and it'll bring that up for you along with some other related policies. So that's all on the home page. I've already logged in, but if you're just reaching the site, it'll have two links on the top right, one to log in and one to register. So if you haven't used the tool before, there's a short registration process, and we need to confirm your email, and then you can be accessing the tool. Okay, I've already launched the tool, so it opens up with the splash screen. Looks like this. And you can directly access help files from it. So if you click on this, you'll get a video on the process of creating an analysis area. And there's each of the major elements in the tool, except for the one I'm demonstrating today because we still have to make that video. These are only 2 or 3 minutes long, and they should get you on your way pretty quickly. Okay, so this is what the tool looks like when it first starts up. It's got this Eastern Interconnection boundary and not a lot else. So the first thing to do is consult the data library. And we'll be talking about energy corridors today, so I'm going to bring up some of the data relevant to that. So if we start out, let's look at transmission. And what I'm doing there is just the column there's a drop-down arrow, and I can filter on it. So I'm doing is filtering on the layer title here, and it's picked up the transmission line existing and planned layers from plats. So the data library has 273 layers in it right now. It's quite a bit to peruse. So you can use these keyword searches and filters. You can filter on category, data source, and the ones that have to do with energy resource are specifically flagged. So if you're interested in one of these energy resources, you can quickly isolate the layers that have to do with it. And then there's a lot of dialogues like this, so these actions on the left are just one-click buttons that do the thing indicated by the tooltip. So I clicked Add it to the map for those layers that I had isolated. So you can see they come over here on the table of contents, and then I can turn them on and off on the map. And then, by the way, if you return to the, say you quit out of your session right now and you come back later, it'll preserve these layers in your table of contents. So you don't have to constantly go back to the data library if there are a set of layers that you use frequently. Okay, so this is kind of a general grid of the United States, and it shows the higher capacity transmission lines. So if I switch to the planned layer, you can see there's a whole variety of planned transmission lines. The green ones there are very diagrammatic in general, and there may be a company that's considering adding links to the grid in these areas, but hasn't really thought about the exact route yet, or hasn't published their plans. And then other ones are more detailed. So like any of these layers, if you use the Identify tool, you could click on that, and it'll show you quite a bit more information about that particular line or feature that you clicked on. So, and I gave this example in a previous webinar. It worked pretty well as a conceptual demonstration, so I'm going to go again. The premise is that the state of Iowa is pretty favorable for wind energy. So I'll just kind of illustrate that as I go. So if I look at wind, let's look at the gross capacity factor for wind energy. That's another one of the commercial layers. And then here's wind farm. This is the data from the USGS. I mentioned their web application. So they've published data about wind turbine locations with a lot of other information attached. So I can right-click and make this transparent. And you can see that there's really high capacity factors in Iowa. And as you would expect, or you might have seen, there's quite a bit of wind development in Iowa. We have power plant models that show the suitability of wind energy. I'm not sure if I kept a second. I just took the default one here. Okay, so I won't be showing today, but this is a map of the energy suitability, taking into account the wind capacity factor, but also a lot of other siting factors related to wind. And I'll make that transparent as well. And previously I'd run this without a requirement to be close to transmission lines. And there were some regions in northwest Iowa that were pretty favorable for wind energy, with the major drawback that they're less accessible to existing transmission. And partially reflecting that, I'm not in the loop on a lot of energy planning. You can see that there's some planned transmission lines. This one here is the one that I was looking at for that example. So the point is, say you're an energy planner for the Midwest and you're trying to see, can we make some more wind capacity available? And so the premise is that we want to add a transmission line. All right, so if we go to the corridors tool here, I previously created some. And the first one, well, first I have to turn on the corridor layer on my map. And if we just take that planned transmission line and sketch it on the map, you can do that with new corridor down here. You can add that line to the map. And then you can take that line and run a report on it. So if we select the corridor report, we can run that for this conceptual line that we drew, and you click Launch, and that will be in your results. Remember, I'm kind of rushing through a little bit of the interface here, but remember there's the help videos that you can use to peruse that information. Okay, so the quarter report, oh, it's still running. So that conceptual line, I can generate a report that has all kinds of information about the things that it crossed and their characteristics. But just a few flags in here. It looks like it's going through a couple more populated areas. So here, get a series of elevation profiles for the different segments of the line. There's some major rivers that it crosses. There's a water body. You typically wouldn't go through a water body. There's some airports nearby that are problematic for being, near a corridor. And then there's some protected lands and habitat issues that occurred. So there are layers for each of these things in the tool, and you can view those visually. The corridor report rapidly takes the ones that are major siting factors and gives you a quick summary of those so you can see what's in the area. And also it would be really difficult to draw a line and try to look at all those layers simultaneously to try to pick a route. So that's where the routing tool comes in that we're talking about today. So if I turn that one off, the tool lets you adjust a corridor manually. So what I can do is if I'm on this one here, conceptual, and I say edit the attributes of this, copy and modify this corridor, I can click on it and I can drag and adjust it so that it avoids some of the features that I see on my map. So that's what was done here. And then I can run the corridor report again and compare it side by side with the first one and see how successful I was in reducing some of the issues of concern. So that's the manual process, and that's what you would do by either drawing it manually or copying a corridor and editing it interactively to avoid some features that you see that it's interfering with. Next, we ran a series of model runs, and these 4 routes were generated. And that's where we really dig into what we're covering today. So I'm going to zoom in a little bit here. Now each one of these was generated automatically by the tool given the same starting and ending points. And to contrast, the original model for roads only included major roads, but we're in kind of a short distance corridor that in an area that has a lot of minor roads. So this first route is pretty impractical. It does follow existing infrastructure pretty much where it can, but it wasn't a very direct route. So in the next case, we adjusted the model to allow it to follow smaller roads, and it found a route that was a little bit more realistic. So that's the general concept of planning routes, is that you're looking at a lot of siting factors and the computer's generating routes for you. As you see one that seems useful or not, you can make adjustments to the model, run it again, and refine that. Another way that's been recommended and used in many cases is to have a workshop and use the systematic process to local stakeholders that are interested in the project, to consult them for the siting factors and actually work with them to weight the siting factors, and then based on their input run a route and look at that with them interactively to see what the alternatives are and what their reactions are to it. So this is the first tool that I'm aware of where you can do this sort of thing interactively on a website as opposed to with proprietary software and quite a bit of upfront data collection and preparation. So all that's been done and made available for you, at least for the eastern interconnection. Okay, so just to illustrate how that was done, what we did was we clicked the corridor tool, chose generate from endpoints, and then specify the two endpoints. Oh, I'm sorry. You have to toggle off any tools that are on here just by clicking them again. Give it the starting and ending points. Let's call it demo. So here, let's say favors roads. Well, that one didn't. Okay, let's try, just for grins, let's try existing pipelines, even though this was supposed to be an electrical transmission. But to show the process, I'm choosing a model that I've run, and I hit save to initiate that run. While it's running, you can look at the results and see the progress. So I have it sorted by the most recent date, and it's showing that as running at this time. You can continue working and do other things while that's running. Sometimes these corridor runs take longer, so you can even quit the tool and come back the next day and look at your results. So all that's saved for you, and once it's launched, you don't need to intervene in any way until it's finished. Okay, so just to clarify, the suitability model tab is used to generate the model itself. So I've run these already, but when you're coming in for the first time, you need to take one of these models or create your own from scratch. And if you click the gear icon, it shows a whole series of siting factors that have been chosen and set up in the model. If you were to click the gear icon in any of these layers, you get a higher level of detail. So for example, in distance to transmission, this default model has these assumptions in it. That if you're within 0.15 miles of an existing transmission line that's greater or equal to 115 kilovolts, then it's 100% suitable. And then as you get farther away from it, the suitability drops off rapidly. And the premise of this layer is that we want to follow that existing transmission line pretty closely. So we're seeking to follow its path instead of just be generally near it. You can adjust any of these weights, up from 0 to 100. If you put 0, which we generally avoid for corridor routing, it will not cross that cell for any reason. So say there's some area completely prohibitive to siting, you would put 0 for that category. So for example, if we look at land cover area, perennial snow and ice probably is not going to be suitable for transmission lines, so we've zeroed that out. It's also a pretty rare land use category. What happens if you zero out too much is that the algorithm won't be able to calculate a route connecting your points. It's usually better to get some result and to review how good or bad it is than to just not get any result at all. So typically we just set them a low value like 1. That makes it a very low suitability for crossing that cell, but it will still cross it if there's no other path. Okay, so I had a series of models already run, and I was selecting from that list when I ran that example just now. Let's see how it's doing. Okay, so that's going to run for a while. That's why I'm going to show you some examples mostly during this demonstration because the time it takes to compute them can be long. Okay, let me switch gears, remove some of these layers. And I have another example, longer distance, that shows crossing the Mississippi and a national trail. And let's zoom over to that area. So here's St. Louis, and our first corridor run uses the choice of favoring existing transmission lines. So this route actually ends up going south of St. Louis, a pretty circuitous route. This area isn't very well developed. There isn't a lot going on in terms of crossing the this is the Mississippi River at the Illinois-Missouri border. And so in this case, that model, based on the routes, went completely around. If you look at favoring major roads, you get a similar result. If you add all roads in, then you get a little bit more direct route, and you find that, when you're not restricting to the major roads, you have a little bit more favorable route there. And if you balance those siting factors, you get a completely different choice. So the point is that there are many ways to get between these 2 points. There's a lot of complex siting factors, and what this lets you do is generate route alternatives based on your assumptions, and you can refine those and make them as detailed as possible as you start to understand the constraints better and see how the route reacts. The assumption then would be that you would generate essentially a study area and some preliminary routes. Sometimes they're called macro corridors, and those would be subject to much more detailed study. So there are siting factors, for example, land ownership, that this tool doesn't address. All the modeling data is sampled at 250-meter cells, so things that are happening at a finer scale, for example, soils or depth of bedrock, or some of those factors are just really beyond the scope of the tool, and you would need to really scrutinize those routes in more detail. So really this tool is intended for creating macro corridors with major siting factors, and so that's kind of on the limitation side. On the positive side, it's taking into account dozens of different siting factors. So if we go back to those suitability models and look at what's in there, we're simultaneously considering all these different features as limitations to corridors with some pre-assigned assumptions. So it can be very powerful for finding routes that are completely unsuitable, eliminating those from consideration, and showing you some possible ones where those negative suitability factors are minimized. Let's see, what's the best way to... So one of the major concerns going into the study that we're doing this year has to do with national trails. So this is funded by the National Department of Energy, the national federal government, and one of the things that they encounter as a challenge for transmission is crossing national trails. So both transmission lines and national trails are large linear features on the landscape, and they have almost opposite management goals. So if I add national trails to the map, let's zoom to the map. So here's a map of the national trails. There are historic trails and scenic trails, and these are protected. Most of them, well, they're administered by local jurisdictions that manage the lands along them with oversight by the National Park Service. But they're protected in terms of preserving scenic resources, and there's a lot more planning scrutiny that has to go on when you're dealing with the national trails. One that you might be familiar with is the Appalachian National Scenic Trail. And if you notice, it goes all the way from Maine all the way into Mississippi. And you can imagine that it's inevitable that if you need to get power from east to west, you're inevitably going to cross that trail. And there are many crossings already. But they need to be minimized. So one of the things that we did was not only to map the trail, but we created a modeling layer that has distance to national trail in it. So the closer you get to the trail, the less suitable that can be in your model. Now it's a scenic trail, and one of the obvious limitations of crossing the trail is how visible are towers or pipeline right-of-ways, that sort of thing. How visible are those from the trail, and how could that be minimized? So there is a technique in geographic information systems called viewshed computation. And we've been talking with Brent Chamberlain from Kansas State University. He has an algorithm that's more advanced for computing viewsheds, and it's a very intensive algorithm. The sample data that you're looking at here took 11 days to run on a workstation. And we're looking at ways that we might be able to employ higher power computing resources for that. But for now, this was run on a fairly high-end workstation. And the green area represents areas that can be seen from the National Trail. The data used was 10-meter resolution, and it represents, and it was computed every 10 meters along the National Trail. So you can see this higher, this brighter color in here. That's a measure of visual magnitude. So what his algorithm does, not only does it compute a viewshed for each of these points along the trail and then combine them, but it takes into account distance and also whether the landscape is facing you or it's at an angle, an oblique angle, and it gives you a higher visual magnitude. Say for example, if you're looking straight on a cliff face, that would be the highest visual magnitude. And then as for example, if you're just looking along a landscape and you can see at a very low angle some feature out there, that's where these dark green areas occur, where they're visible from the trail but not dominantly. So what we've done is made this into a modeling layer where you can weight visual magnitude as a sighting factor. So I was just experimenting with some of those today, and to illustrate that. Okay, I use slightly different endpoints here, but the results are pretty similar. Let's go without the viewshed. So this route is generated between the 2 points without a viewshed. And if we would use a model, this is the general model, so it's not really highlighting roads or transmission specifically. It's got a whole slew of general sighting factors. But there are a lot of factors that have to do with land cover type. Forested is low, protected lands are low, habitat is low suitability. So there's a lot of factors that would tend to push it away from the trail in general, and that's what's happened here. But you can see this white area. This is an area that's not visible from the trail in this viewshed. And if you look at the one that was generated with the viewshed, you can see that it's sighting, it's routing the corridor in that valley that's hidden from view from the trail. And then they both have a crossing in the trail that was part of the purpose of the example to show, actually crossing at a fairly high impact. So I would have thought it would come through here. One of the things that we have right now is a lower resolution for modeling, so that's reflected in this result. We're not modeling this at this highest resolution. But the point is, it's crossing the trail almost perpendicular, and it's crossing it at a place of lower visual intensity. And in general, it's sited it in an area up here where there's no added cost for being visible from the trail. That's generally the process of generating corridors with the tool. And I just want to stress the importance of, we've set up these default models, and there's a big library of suitability factors, but these are just starting points. So they allow you to quickly try something and run it, but really a lot of scrutiny in the sighting factors is important. So I would recommend that you spend some time looking at these sighting factors, understanding what they are, why they might be important for your particular project needs, and then adjusting the parameters for your own needs. So for example, for land cover, I have heard cases where forest is favored for a corridor instead of less suitable. It may be that there's ample forest land in the area, and the forest would obscure the visibility of the transmission line. So you could increase the suitability for forests if you had that in mind. For the power plant models, well, in general, we've made agricultural land a little bit higher in suitability. But for example, for center pivot irrigation, if you have a lot of that in your region, it's not very compatible with transmission line towers because they would interfere with the center pivot irrigation. So you might want to, reduce the suitability for cultivated crops. That's just one example. If you look at something different, there's these different air navigation features. It's not so much that those are, the sighting factor for transmissions, but if you're going to be right on top of or close to one of these air navigation systems or radar systems or airports, you're probably not going to be very successful in sighting a corridor. So the default factors, for example, for airports, is that you're not 100% suitable to your 5 miles away from an airport. In that first example I showed you of Iowa, there's some small local airports there, and there are transmission lines that are relatively close to those airports. So in that case, at a larger scale, you might want to relax the restrictions because this particular layer doesn't distinguish in the size of the airport, and there's only certain levels of refinement we can get at. Some major ones here are protected land and habitat. These are combinations of a whole slew of sighting factors. So we've got different sensitivity levels. So, for example, a national park would be excluded from development. And there are cases where power lines cross National Park Service jurisdictions, and if there's really no way to go around that, you might relax that assumption and still try to find a route that satisfies the rest of the sighting factors. So what I'm getting at here is, a lot of work has been done for you to gather the data, put it in a form useful for modeling, make some default assumptions, and give you a tool that you can run these routes. But the important thing is that if you want to do some serious corridor routing work, you really need to dig deeper into it. I want you to see how it works and try try to tailor the parameters to your exact situation. So there's these default layers. In any of these models, you can click Add Layers and access the whole mapping library. So there are a lot of other siting factors that are present. For example, proximity to a railroad. My understanding is that railroad companies generally would have liked to avoid having transmission lines near their right-of-ways, but that might be a way to get through a tough area. So the point is, you can add these, you can subtract them by clicking the red icon, adjust the model as parameters as needed, and set it up for your own purposes. All right. So I think that covers what I was going to share today about corridor routing. And we have a little bit of time left for questions, so